You're listening to the CaribClimate podcast, produced by the Investment Plan for the Caribbean Regional Track of the Pilot Program for Climate Resilience, funded by the Inter-American Development Bank through the Climate Investment Funds, and implemented by the Project Management Unit of the University of the West Indies Mona Office for Research and Innovation. Both research and reality shows that climate change will continue to threaten the Caribbean region's food security. In this episode of the CaribClimate podcast, Dr. Gregory Robin, former country representative for the Caribbean Agricultural Research and Development Institute, CARDI, in Jamaica, shares how the agriculture subcomponent of the Caribbean Regional PPCR, led by CARDI, improved availability of climate-resilient plant varieties and agricultural production systems.
Well, first of all, let me thank the PPCR for inviting me to the podcast on issues of climate change and food security. In the region, I think climate change has affected food security mainly from the point of view of drought and prolonged drought or dry periods, where farmers without irrigation or any source of water have difficulty in growing and sustaining crop production. I also want to think that there can be periods of prolonged, intense, heavy rainfalls, especially in the islands like Dominica, Jamaica. Some of the islands do experience intensive, prolonged rainfall. But with proper drainage, I think most farmers are able to counteract issues of waterlogging, where we have hard pans and high water tables. Good drainage aids taking the water away. And therefore, unless you're in the low-lying areas which are prone to flooding, intense prolonged rainfall is not necessarily as problematic as prolonged dry periods that lead to intensive drought. And let us remember, in dry islands like Antigua or the Leeward Islands, or in Jamaica, St. Elizabeth, really dry areas, the water catchments in prolonged dry periods will dry up so that your sources of water are also dry, and that really affects production. In some instances, in small farm situations, the trucking of water to these farms mitigates against some of the problems of drought. But drought is probably the main, prolonged drought, dry spells, are arguably the main problems that farmers face in the region. Of course, the frequency of storms and intense hurricanes have disrupted the production system, disrupted food production, disrupted exports to neighboring islands, disrupted interregional trade, and all that affects food security. Because food security is not only from the point of view of producing in your country for your consumption. A lot of our commodities have to be imported to support certain aspects of local production, to support our food security programs. And therefore, one hurricane strike, they disrupt the trade links, they disrupt the ports, and that does also affect food security significantly. So these, I would think, are the major climate change factors that we see affecting food security in the region now.
Let's find out, in what ways have climate change impacted food security in the region?
Okay, the PPCR project targeted and helped us to mitigate against climate change issues and food security issues in three major ways. One, it allowed us to investigate potential local accessions have of being drought tolerant. So we were able to assess one of the major food security crops in CARICOM, selected by the government, sweet potato, we were able to assess the potential of local accessions for drought tolerance. And we were able to do this very satisfactorily. We were also able, at the molecular level, to work with the University of the West Indies, Caville campus, to assess the very accessions genetically for genetic characteristics that show drought tolerance. And that's supported by the local drought-tolerant trials. We were able to corroborate accessions that were very capable of withstanding prolonged drought periods. And when I say capable, they were able to produce a crop at an average production rate or level, whichever you prefer to use. So even the sweet potato varieties were grown and produced during the dry periods, and we got satisfactory production. And as I said, we corroborated that at the molecular level, and we were able to get drought tolerance genes, salt tolerance genes in these accessions, and provided a very useful basis for having genotypes that can be used by farmers, especially small farmers, in their production system. Now, it's one thing to assess and identify the phenotypes that have drought-tolerant characteristics. Next thing is to get these phenotypes, varieties or accessions to the farming community. And the PPCR project systematically dealt with the issues in many different ways. We upgraded the gene bank in St. Vincent, which is a tissue culture laboratory, and that can house, multiply, and disseminate genotypes to the islands. So we're able to port genotypes to the lab in St. Vincent. They were cleaned up, held under sterile conditions, multiplied up, and then distributed to the various countries that were interested in the genotype.
Given the range of threats to regional food security, how has the PPCR project supported resilience within the agriculture sector?
Then the project did something which I thought was very interesting, in that when you export the tissue culture plantlets to the various islands, and these would be the project countries, of course, we were able to receive tissue culture planted material in weaning and hardening facilities provided by the project. And these weaning and hardening facilities were basically greenhouses with a plastic covering, virus mesh screen on the outside to prevent vectors from transmitting any unwanted viral diseases. And we included a misting system or some form of irrigation watering system in the weaning and hardening facilities, preferably a misting system. So we were able to vegetatively now multiply up the sweet potato plantlets and then distribute the slips to farmers. Farmers did not get tissue culture material because they don't have facilities to wean and harden. So the project provided the facilities so that the ministry or CARDI could wean and harden these plantlets and distribute to the farmers.
The Caribbean Regional PPCR and CARDI have ensured a robust approach to preserving climate-resilient plant varieties. Controlled lab environments and protected agriculture structures were some of the major ways the project was able to preserve and protect climate-resilient planting material. Dr. Robin gives more detail on how the gene bank has supported recovery from extreme events.
The project didn't start a gene bank from scratch. There was in St. Vincent a particular gene bank which was established on the CARDI project. And that gene bank focused on root and tuber crops. The sweet potatoes, cassava, yams, dasheen, and all these are really food security crops. These are the indigenous root crops in the region, which every household, every small farm produces, and they constitute a major part of the food security. And you can imagine, we've had experiences in the region where prolonged drought has literally wiped out many of our genotypes or accessions in the field. However, we noticed that there's some accessions that did survive, and therefore the project scientifically assessed the genotypes or accessions, and we did that both in the field for agronomic studies. So we did the sweet potato agronomic studies, and the climate service group at Mona did the cassava agronomic studies. The drought tolerant trials listed were done on the CARDI Mona campus experimental station. The data collected there was used to assess and come to the conclusion which accessions were drought tolerant. In other words, they could survive and produce a crop under dry conditions. To support that, we genetically assessed the very accessions or genotypes. And we did that with the support of the molecular lab at Kville campus. And that would be Dr. Angela Aline led that study. So we took leaf samples from the accessions, dried them, and under specific conditions, couriered the samples to the lab in Barbados. We also did that for sweet potato accessions recommended by the ministries in the project countries. So St. Vincent, St. Lucia, Grenada, Dominica also sent in samples to the lab in Barbados following the protocols given by the molecular lab. So all these islands have a clear understanding of the accessions of interest to them, and the interest lies along the lines of food security, consumer acceptance, exportability, and processing.
The regional PPCR effectively enhanced infrastructure critical to Caribbean agriculture needs, as well as capacity within CARDI and other stakeholder institutions through the provision of training opportunities.
I think the PPCR project, and remember, I was the project manager from CARDI side of that project, did contribute significantly to training and improving capacity of young regional scientists and technicians. Not only the CARDI technicians and scientists, but also the ministry scientists. And from what I can remember, we had lots of sessions around the region. In some instances, we sent technicians and scientists to the States, to specific institutions. For instance, in seed technology, we sent the research officer and one of the technicians in the seed lab. And remember, CARDI supported the rehabilitation of the seed lab at Bodles through an EU-funded project and then the PPCR project. What the EU-funded project did was to provide the equipment, and the PPCR project provided the funding for the infrastructure, most importantly, the infrastructure and the generation of electricity, because a seed lab has to maintain constant cooling temperatures, irrespective of whether there's a hurricane, drought, storm, whatever, heavy rains. So that is a self-contained seed lab. not only for storing true seed, and when I say true seed, I mean like tomato seeds or hot pepper seeds, but also dealing with vegetative seed. So it could take a tissue culture plantlet from the same gene bank in St. Vincent, equipped by and refurbished by the PPCR project, and multiply it up and improve its seed supply for Jamaica through the seed lab in Jamaica, which was rehabilitated by the PPCR project. So there's nothing done in isolation. It's a whole network of events that the PPCR project did where seed is concerned. And seed storage is a major part of your food security, because after a storm, you need to distribute clean seed material to your farming community. I'm talking about clean and viable seed material.
Seed storage, biorepository facilities like the gene bank, and protected agriculture structures like the weaning and hardening facilities play a huge part in securing our food future. But how do they strengthen regional cooperation in the face of climate change?
So seeds stored under the specific ideal conditions in seed lab in Jamaica would be disseminated through the region. So the lab can house important genetic material, indigenous genetic material for the various project countries, and multiply the seed material and distribute it back to the islands if there's a natural disaster in any case. Now, on top of that, the project, recognizing that it can't do all of this stuff in one country, because having a seed facility in one country is not a wise thing in case you have a major national disaster. So we supported upgrading facilities in Belize and Antigua, where CARDI has significant seed production and storage facilities for the region. And Antigua, as you know, is the largest producer of West Indies red and Scotch bonnet seed for the region. The Scotch bonnet seed is specifically an agreement between Jamaica and CARDI. Belize produces other pepper varieties and a lot of corn and soy for Belize and the region also. They also produce a lot of beans. And you know, Belize is probably the largest exporter of red beans to Jamaica. You know, you consume a lot of red beans. So the project has a lot of tentacles in supporting facilities that ensure that we maintain our seed in good condition, and both true and vegetative seed. It allows us to distribute the seed to the CARICOM countries in the best conditions so that we can sustain our production systems. But not only that, we trained seed scientists from Boodles 2, from Trinidad 1, from Belize 1, and I think Guyana 1. So we trained about 5 seed technicians from around the region in the States in all aspects of seed production technology. So I think the region has really benefited not only from training, infrastructural development, but developing a systems, sustainable systems for distributing clean planting material to countries in normal times, but especially in times of disaster when food relief is essential, and rehabilitating acreages of crops for food security is very, very important. So the seed lab is set up to deal with all these issues.
The PPCR and CARDI together sowed seeds of resilience, which yielded success in the provision of needed resources to combat the climate challenge.
All right, I think we won. Most of the islands and the region as a whole, we don't have the resources to build infrastructural capacity to service our agricultural production systems. By the project providing refurbishment of seed labs at borders and providing weaning and hardening facilities to accept tissue culture material from both borders and the gene bank in St. Vincent, which is also refurbished under the project. It's a huge step in the right direction to support Caribbean agriculture. And I think the project has received rave reviews from the Minister of Agriculture at the time in Jamaica for the lab in borders, which he was there at the launching. The lab in St. Vincent was affected by the recent volcano. So I'm not sure what the status of that is now, but the volcano did affect the progress on that lab. But the weaning and hardening facilities are erected in most of the countries. And I think they just need to put in one or two things for the irrigation systems, and there will be multiplying of tissue culture material for the region. Training, we benefited significantly from training in modeling. And that was conducted by the Climate Service Group from Mona, Dale Rankin. So we did quite a bit of work in modeling. Probably CARDI did not necessarily have all the resources as an institute to set up the kind of experiments to ensure that the scientists in CARDI could use the modeling methods they learned with the support, of course, with this Climate Service Group. I think if CARDI had the resources to put down the type of experiments, to generate the kind of data to go into the models with the support of the Climate Service Group at Mona, I think that would have been fantastic. However, the scientists were trained. They were trained in two phases, basic and an advanced phase. And I think they were very, very, very enthusiastic about carrying out the experiments. It's a matter of resources, but that is really a CARDI issue. So the project has done quite a bit in terms of educating young scientists, getting them to understand the values of using information in modeling to do projections in the production systems. Though this probably still is in its infancy in terms of being used in small farm production systems. But I think the Climate Service Group is doing some tremendous work supported by the project in developing models, especially for cassava and sweet potato.
Building on the regional PPCR and CARDI's joint efforts, what should be the next step to reinforce the agricultural landscape across the Caribbean?
I think the region is falling short on using applied science in its agricultural production systems. Falling short. I think the PPCR, through the Climate Service Group and Mona and CARDI, made some inroads there. It would be nice to see that we continue along that path. And that's where I'm going to leave it. Because if I take one thing, for instance, the sweet potato work and the molecular genetics to identify accessions around the region that are drought tolerant, and the experiments done in Jamaica to corroborate with the molecular work done at Cairville was fantastic. And we had a webinar on that. And it generated a lot of interest. Scientists are now seeing, look, it's not only field work, we can do the molecular at the genetic level and give some good scientific evidence of our findings. That was done in only 6 countries. We wrote up a project to try to continue that in the other CARICOM countries. And I'm not sure where that is. But when I say the use of applied science in our agricultural systems, we're falling woefully short there. And we depend too much on funding agencies to do that. Funding agencies sometimes have more of a developmental slant, not too much of a research slant, and therefore it makes it difficult for scientists to do applied research on some of these projects. So the governments now would have to pick up that slack.
The CaribClimate podcast is produced by the Investment Plan for the Caribbean Regional Track of the Pilot Program for Climate Resilience, funded by the Inter-American Development Bank through the Climate Investment Funds and implemented by the Project Management Unit of the University of the West Indies Mona Office for Research and Innovation. The CaribClimate podcast, using data to make climate resilience greater.